So you want to find out the perimeter of the circle, which is 2 pi r, right? According to how we calculated. And now let us see if this is actually coming out to be that or not. The radius is 1 over here. We are opening this whole line. We're putting it on the number line. How much is the length of the whole side which was around the boundary? How much is the length?
6.3.
Yeah. Okay, so over here, yeah. So we can say approximately 6.3, right? The whole length is coming out to be. And this is a circumference when radius was 1. Now, if we see here, 2 pi we have calculated is 3.14 and radius is 1 over here. And if we do the multiplication, 6.28, which is 6.3, which is the same, right? We can take any other example also over here. Let me show you another one. Okay, here. Is this screen visible?
It's the same one as before.
Has this thing changed that there is a green?
Yeah, now it changed.
Okay, let me erase this part now. See, we have kept some diameter. Let's say diameter is 3 and we are unrolling it. Diameter is 3 and diameter is 2 times radius. So diameter is 3, they are saying. And the circumference is 2 pi r. So circumference is 2r, we know was 3 times pi. And how much is this approximately?
9.4.
Yeah, 9.4 we can say. And here 3 times 3.14. If we calculate this, we are getting here 4.9. So approximately 9.4 only. So when we had done the calculations, this was the formula. What was happening was we were getting the relative 2 times r there, which was this thing. But there was still a little bit was left. And this was by calculations found out to be 3.14. And whenever we are just plugging it in, the answer was coming exactly the same. So we were finding out the circumference relative to what was the radius or the diameter. So that's how we came to know about the formula C is equal to 2 pi r for the circumference. Similarly,
Got
we just we can just change the units here. The diameter, unroll it. Then let's keep the diameter here. Let's say 5 here. And now we unroll it. And now you tell me. So what is the diameter here is 5. Diameter means 2 times r. And over here, what is the circumference showing to be?
15.2.
15 point, isn't it? 2 here.
Sorry, 15.8.
Yeah, can be said. So it's around this and this, yeah, 7 or 8 something. So if we just check out the line, let me just make it smaller so that I can count it here. And this is the one we are talking about, this line. What number is that line?
2 point, no, 15.8.
Oh, 15.12345. This bigger line, longer line is 5.
7.
15.7 units. Now, if we do it with the formula C is equal to 2 pi r, we know this 2r is actually 5. 5 times 3.14. So over here, 5 times 3.14. 5 fours are 20. 2 carry. 5 ones are 5. 6, 7. 5 threes are 15. See? It's the same. When this was found, na, we suppose we did not know what is the value of pi. Then what used to happen? That they tried to find out what is that pi that we are talking about. So over here, we wanted to find out how the circumference is related to the radius. So we just came to know about that there is something which is 2 times r, and there was something we don't know. This was pi, later on called. Let's say that was x. So we found that is this is 15.7 over here on this one, and this is 2 times r, and 2 times r we had taken as 5, 2r. The diameter we had taken as 5 times the x. Now 15.7 divided by 5 is equal to x. How much is it going to have? Is it going to give us? 5 times 3?
18.7 divided by 5.
Yes.
5 times 3 is 15. Uh, add 0, 70.
Will it go on 5 table?
No,
5 on the 5 is not going?
it goes one time. Sorry, my brain's still asleep. It goes one time.
It's okay. Now,
0. Make it 20.
Hmm.
4. 3.14.
Yeah. So similarly, when we had the circles, we calculated manually what was the circumference, and we've tried out formulas how they were related with the radius, how they were related with the diameter, and we found there was still a number which was not, coming in the calculation. So by all the calculations and all the stuff, they found out that number was approximately equal to 3.14, and that's what we are calling as pi. There are still, pi is the only number which whose digits never repeat. Like we still have not find there have been lakhs and lakhs of numbers after 3.14 and so, but there are still numbers which are not yet repeated. So over here now, if we want to find out the area, similarly our pi, which we found was an irrational number, similar going on never repeating, is number one. And now, what was area was? Do you remember what was area and what is the difference between area and circumference of anything?
Area is the inside, and circumference is the outside.
Yeah. If this is a box, this red colored boundary is what we are going to call
Is
as
the
its,
circumference,
yes, as a circumference.
right?
And whatever is the inside part, we are going to call that as its area. How much has been covered is going to be the area. So see, similarly over here, this was a circle, and outside line we have created, and that was a circumference. Now what do we do over here is that we want to find out the area. Area is the how much has been enclosed in the inside the lines. So we have this line, which is the radius. We have this line, which is making the circumference. So how much has been covered inside it? This thing. So we just joined a line over here with this, and we want to find out what has been inside this particular thing. Let me highlight this. So we want to find out all the things, all the part which is inside the area. This is what we want to find out. So we want to find out the area. This looks like a triangle. And now, as it looks like a triangle, we can use the similar thing with the what is the area of a triangle. So area of the triangle, do you remember?
No, it's been a while.
No worries. It's half of base multiplied by height. So this is our
Right.
base and this is our height. And height is just nothing but the radius. Base is nothing but 2 pi r. So 2 pi r times r. This 2 and 2 gets cancelled. Pi r times r is pi r squared. So that's how we found that the area of a circle is pi r square. Do you have any questions here?
No
Do you like to see?
questions.
Would you like to see another one?
Sure.
Okay. Now see here. Is this visible?
Yeah.
Mhm. Now see, this is again a circle. We have divided the circle in small, little, we can say triangular shapes. If we just keep on increasing the triangles, it will be looking like a proper triangle, who has a, what, flat base, horizontal base, right? Looking like one.
Yeah.
If we increase the number, yeah, there will be so many triangles inside. We're keeping it in medium, then we are opening it. We are rearranging it here. So we rearranged it, and we know that the shape, which is the shape of the circle, looks exactly like, what do you think? What does it look like?
Grass.
Hmm? What?
Grass.
Okay. And
But it's a
what?
rectangle.
You're almost similar like a rectangle if we have enough triangles there. And what is the area of a rectangle?
Area for rectangle.
Hmm.
Wait. No, I don't remember. I need to write these all down.
This was length, this was breadth. It was length time breadth. The
Oh, I
area
should know this. Why don't I know this?
It's okay. The area of a rectangle was length times breadth. Now see,
I remember learning it, but I don't know why it's not coming back to my brain.
no worries. I think you just woke up. That's why. See here. Now this is one half of that circle, and let's color the other half differently. This color is not even showing. Let me color this yellow. At least it's showing. Yeah. And we know this yellow and this red. What are they making this boundary when we add them up? This yellow and red boundary whole, what does it make? Is it making the boundary of the circle?
Yeah.
We just found out what was the formula for the boundary of the circle.
That was C
Yes. Circumference, which was?
2 pi r.
Yes, very good. 2 pi r. So r is the radius here. From the center, any line that is coming towards the boundary, be it here till the boundary, here, anywhere, that's our radius. So these are all radii. Now see, one side, there is a yellow being covered. Yellow is being covered on the orange side, correct?
Mhm.
and then there is red being covered, which is on the green, this side, right? Now we know that the full circle's boundary is 2 pi r. Then what is the half circle's boundary? Full circle's boundary is 2 pi r. What is half circle's boundary?
Half circle's boundary.
Hmm.
Pi r.
This is, yes, very good. So we will be halving this 2 pi r, which is pi r. So this red portion is also pi r, this yellow portion is also pi r, right?
Yeah.
And these lines which are coming from the center to the boundary, these blue ones, these are the radii, right? That means what are these? What are these lines then?
Quarters. No.
No, any line, not portion. These lines,
Uh, um. The radius.
radius. So this and this is also radius, right?
Yeah.
All these inside are radius. We know area of the rectangle is length times breadth. So area of this will be also length times breadth. We can say this is length. We can say this is breadth, right? So length is pi r and breadth is r, which makes it pi r squared. So that's how the area is pi r squared. Any questions here?
No. Wait.
Okay.
Area of a circle is pi r square.
Yes. Area of the circle. See, area is what?
Then
Yeah.
what's 2 pi r? Is that the
What was the difference between
the
area and circumference?
oh so yeah, I got it now.
Oh,
Thank you.
great. Oh, great. All right. So area of a circle is pi r squared and circumference of the circle is 2 pi. And we got to see how actually they are formed. Should we go with the practice of questions?
Yeah, 1 minute. I'm just gonna quickly write it down.
Let me bring it back then.
No, it's okay.
You remember?
Yeah.
Great.